Hey guys, it's Mr. Bosher, and today we're going to talk about how we determine if a conditional statement is true or false. Okay, so all I'm going to do today to show you that is I'm just going to work through probably just a couple examples, unless I feel like I need to do a few more once I get past 2 examples. Okay, so we'll see how many we do. And I'm just going to kind of show you the process and how I think about it. And like, how do I determine if something is true or false with these statements? Okay, so the main idea in determining if a conditional statement is true or false is that we need to check if the if and the then are both true. Okay, so the only time a statement is true, so let's write this down. So a statement is true if the if and the then are both true. Okay, seems simple enough. If one of these is false, so let's say like the if is false, but the then is true, well, that doesn't really mean anything, right? Because if the if is false, that means that our condition, so if you look at our problem right here, the given statement says if a light bulb costs $3, then the light bulb was yellow. Well, if the if part of the statement is false, that means that the if didn't happen, right? So we have a light bulb that does not cost $3. So in that scenario, I don't really care about the rest of the statement then, right? Because I didn't meet the condition or the if at the beginning, right? It's kind of like when we did Pythagorean theorem. If I don't give you a right triangle, are you going to even bother trying to use the equation? No, because we said our theorem said if we have a right triangle, then I can do the equation. So if I hand you just some random shape, you're not going to think to use Pythagorean theorem, right? Because it doesn't really apply. So that would be a false statement, or at least not exactly a false statement, but it's just like we don't really care about that statement, right? Because we didn't meet the if or the condition. So that scenario is one we don't want. Obviously, if both are false, that's not helpful because we still don't have the if, right? We still didn't meet the condition anyway. And the second part is not, still doesn't matter. So obviously we don't want both parts to be false. And then the last scenario is, what if the if is true, but the then is false? This is like super false. Okay? So when the if was false, it was just like, well, we don't really care, right? Because we're not even starting the statement out correctly. We don't even have the condition, so it's not really worth asking. But if I do hit the condition, so like in our problem it says if a light bulb costs $3, but then the light bulb was not yellow, well then your statement at that beginning would definitely be false, right? Because I said the beginning part happened, but the second part did not happen, right? So if someone told me that statement, but the second part wasn't true, that would be very, very, very false. Okay? So that's basically what we're checking. Does the if happen? If it does, cool, that's true. Then we check, does the then actually make sense? Right? Is it also true? So to sort of reword this, when I say I want both of these true, what does that mean? Well, for the if, it just means that it happens, right? I just need it to happen in the first place. I need that first statement to be met. Right? I need that condition to happen. For the then, I want you to think of it as always true. Because sometimes people make statements and they're not completely wrong, but the way that they write the statements doesn't give you the full picture. Okay? So hopefully we'll get some examples of that as we go through some problems. And that when we look at the then, we have to check, is this always true in our problem? Or is it only kind of correct? Right? We want statements that are 100% correct, not kind of correct. Okay? So let's just go through that. If the explanation isn't helpful, we're just like writing it here, don't worry. I'm going to do the thought process in the problems and hopefully it will click. Okay? So let's go back to the assignment. And let's start with our given statement. Okay? It says, if a light bulb costs $3, then the light bulb was yellow. Okay. So what I'm going to do, I'm going to go back to where I can write on the page. And I'll use blue for this one. And it says, if the light bulb was yellow. If a light bulb cost $3. So I'm going to go through and look at all my costs for a light bulb that's $3. So I have this cost of $3 and I have this cost of $3. Now I look at the second part of the statement and it says, well, then the light bulb was yellow. Okay, so I check and I say, well, this one's yellow, right? That's fine. But is this one yellow? No. So is the second half of my statement always true, or is it only kind of true? It's only kind of true, right? Because I could buy a $3 light bulb thinking I'm going to get a yellow one, but actually buy a green one. So if I followed this statement that someone gave me and I thought it was true, I could potentially be lied to, right? Because I could get a green light bulb at the end. Okay? So we would go over and say, well, this is false because I made the if happen, right? I found a light bulb that was $3. However, they're not always yellow. They're only sometimes yellow, right? They should have said the light bulb will be green or yellow. Then they would have had a true statement, right? But because they only put one, it doesn't work. Cool. So we would go back to our assignment and we'd say that one is false. Simple as that. And then you go through and you say, okay, I want to do it for the converse now. So remember that the converse, we'll just work through the whole problem. Well, oops, I don't want that one. Remind you real quick that the converse is when it's like a coin, right? Converse, the word coin is kind of in there, or it's very close to saying coin. So when we can flip a coin, so we're going to flip the P and the Q, right? That was our best way to remember it. So we're going to say Q, then P. So we're going to swap the if and the then in our statements. So what is that going to look like? Well, we'll go back. Well, if the second part of my original statement was then the light bulb was yellow, I'm going to put that at the beginning, right? That's what you guys have been working on from the last lessons. So I'm going to say if the light bulb was yellow. And then my then is just going to be my original if, right? Because they swap places. So the light bulb cost $3. There we go. So now we have our statement. So we're going to check, well, is it true or not? Right? When I swap, when I go from the given statement to the converse in this problem, will my truth values change for the statement? Well, let's find out. So let me get back to where I can write. And it says if a light bulb was yellow, so we're just going to go through and find all the light bulbs that are yellow. So I'll use green. Oh, well, yeah, we'll use green. Okay, so there's my one light bulb that can be yellow. And then my statement says, well, then the light bulb has to cost $3. Well, in my one scenario, does it cost $3? It does. So is this always correct? Yes, right? Because it's the only situation where we have a yellow light bulb, and it also happens to cost the $3. So that is always true. There are no other scenarios, at least in our table that they gave us, right, to make this false. Obviously, in the real world, if we said this, maybe not true. But maybe this is the table for, like, a Home Depot or something, right? Well, then it'd be true for that store. So this would be a true statement for our problem. So we're going to go back, and we're going to say that this one is true. Mark that as true. Cool. To save time, I'm not going to write out the formulas for contrapositive and inverse. We're just going to do them here, okay? Because we should be comfortable with these now. I'm just going to sort of explain. So contrapositive, remember, is when it's the most complicated word, so it has the most complicated formula, right? We're going to have to swap the P and the Q, and we're going to have to negate the P and the Q, all right? If you're not sure what I'm talking about, watch the previous 2 videos on this topic, okay? Your 2 previous video lessons, because we should be pros at writing these by now. All right, so contrapositive, I have to swap them and negate them, or add the not, right? The word not into them. So my original if was a light bulb cost $3, So that's going to go at the end and have the word not put on it. So I'm going to say, then the light bulb does not cost $3. And then the original then statement said the light bulb was yellow. So now that's going to be my beginning statement, or the if, and I'm going to say was not yellow. Okay, so now we're checking if a light bulb was not yellow, then the light bulb did not cost $3. All right, let's go through and check that. So let's go back to where we can write. We'll use red. And let's see, if a light bulb was not yellow, the light bulb did not cost $3. Okay, so we're going to say, well, green's not yellow, red's not yellow, white's not yellow, purple's not yellow. So now I have to check for all of these scenarios, does the then statement always work, right? Does the light bulb always not cost $3? Well, it works for purple, it works for white, it works for red, but does it work for green? No, that does cost $3. So the contrapositive is only kind of correct, but is it a completely true statement? Absolutely not, because the green light bulb ruins this statement, right? Because it does both parts. It says it's a light bulb that's not yellow. However, it doesn't follow that it shouldn't cost $3, because it does cost $3. All right? So we're going to say this one is false. And then we move on to inverse. Remember, inverse in algebra meant opposites, right? Opposites in logic or in conditional statements means that we're going to add the word not, right? We're going to negate them. So my original if statement was if a light bulb costs $3. So my new inverse statement is going to be if a light bulb does not cost $3. Okay? And then my then statement, let's see, was the light bulb was yellow. So my new then statement is going to be the light bulb was not yellow. Right? Because the inverse only negates the original statement. It doesn't swap them around. It just puts the word not on each part. Okay. Now let's go see. What is the truth value of this? Is it going to be true or false? Well, the if says if a light bulb did not cost $3. So I'm going to first go through and see, well, when does that happen? So not $3 would be 5, 2, and 6. Okay? Those are my 3 light bulbs. And then the then statement said the light bulb should not be yellow, right, in this scenario. Well, we get red, we get white, and we get purple. So is our then statement always true? It is always true, because we did not get yellow in any of our examples. So this would be a true statement. Okay? That would be a true statement. So our final answer would look something like this. And that's how you do this problem. Okay? I'll try to do one more. And now that we kind of see what we're going for, we can probably do it a little bit faster. And there's only one thing I want you to sort of pay attention to as you work through this assignment. I want you to see if you notice any patterns about what question or like what statements are true and what statements are false, and so on, right? So like in this one, we have the given, the beginning, it was false, but the converse was true. The contrapositive was false, but the inverse was true, right? So changing the way that we write the statements does change the truth values, at least in this example. And I want you to, as you go through this problem or this assignment, just kind of be like, hey, do I notice any patterns here? Because that might help us with our next conversation when we go into next week, okay? So just keep that in mind. Do you notice any patterns as you go through that there? Okay? Let's do, let's see. Hopefully I didn't mess anything up. Awesome. Let's try another. So now our given statement says if an item is a pendant, then the item is made from copper. So let's go see. So if the item is a pendant, then the item is made from copper. So let's go see if I have a pendant. That seems to be the only pendant there. So in that one scenario, is the item made of copper? Yes, it is. So is our then statement always true? Absolutely, right? Because we only had the one scenario, and in that one scenario, it did work. So this would be a true statement. All right, mark that as true. Now it wants the inverse, okay? So the inverse was, we don't swap them, we're just going to put the negations, right? We're going to add the word not with the original statement. So if my original if was if an item is a pendant, my new if is going to say if an item is not a pendant. And my original then said the item is made from copper, so the inverse then would say the item is not made from copper, right? Inverse only adds the word not. All right, let's see if this is true or not. So if an item is not a pendant, so we have a ring, a bracelet, a necklace, and a hairpin, is the item always not going to be made from copper? Well, we get silver, we get platinum, we get gold, but we also get copper, okay? The necklace is not a pendant, but it is still made from copper, so that kind of disproves the inverse statement there. That would be false, because it's not always made from copper. Okay, so we go back over here, and we say that would be false. Okay, because the necklace is not a pendant, but it is still made from copper, so that would show us that that statement does not always work. Now, contrapositive. Remember, contrapositive is the most complicated word, so it's got the most complicated formulas, right? It's going to have to do everything. You have to swap the if and the then, and you have to negate them, right? You have to add the word not. So contrapositive, the original statement said if an item is a pendant, so now we're going to put that at the end of the statement on the then, and also add the word not, so we're going to say then the item is not a pendant. The item is not, not that one, is not a pendant. And for our original statement, the then said the item is made from copper. So now it's going to be our if, and we're going to add the word not. So it's going to say if the item is not made from copper. There we go. Now we go through and we check. Is this true or false? So we go back to where we can write. We'll use red again. And let's see. So we're checking if an item is not made from copper. Okay, so that gives us silver. That gives us platinum. And that gives us gold. Those are all the things that are not copper that we can make stuff out of. And we want to check if the item is not a pendant. Okay. Well, when I use silver, I got a bracelet, so that's not a pendant. When I use platinum, I got a ring. That's not a pendant. And when I use gold, I got a hairpin, so that's not a pendant. So in every scenario where we did not have copper, we also did not get a pendant. So is it always true? Yes, this is always true, at least in this scenario, right, in this problem. So we could say, cool, that means that the contrapositive is true. And now lastly, the converse. Remember, converse looks like it has the word coin in it almost. So that means we can flip a coin, so we're going to flip the if and the then. Okay? So our original if was an item is a pendant. So now I'm going to make that my then statement. So the item is a pendant is the then. The original then was the item is made from copper. So that's going to be the new if. So we have if an item is made from copper, then the item is a pendant. All right. So let's check. Is that going to be true or false? We use yellow. If an item is made from copper. Okay. So where are my two coppers? I have these right here. Then the item needs to be a pendant. Well, that works for this line. Oops. That line. But we also can make a necklace. So is the converse statement always true? No, it's only halfway true, right? Sometimes we'll get a pendant, but we can also get a necklace, and you didn't tell me that. So that is not a completely true statement. So we're going to actually call that a false statement. Okay? So try to remember or rewind the video, right? And go back to our finished first problem, and then compare it to this finished problem. Do you notice any patterns? Let me get back to where I can write to sort of help you out here. There's a shortcut in this assignment. Because if you notice on the last problem, your given statement and your conditional statement had the same answer for if they were true or false. And if you notice on this problem, the given statement and the contrapositive have the same answer if they were true or false. Same thing with the inverse and the converse. On the first problem, they were both true, so they match their answers on if they were true or false. And on the second problem, they're also both false, right? They're still matching. So there is a way for me to show you this and prove this, but I'm only going to do that once I'm back in person if you guys want to see it. But there is a reason why these match, and it's because they have the same truth, okay? The wording, when we move it around in those specific ways, right, from given statement to contrapositive, always results in basically you saying the same thing, but in a different way. So their truth values will always be the same, right? So if the original is true, the contrapositive is true. If the contrapositive is false, then your original was true, right? Or sorry, if your contrapositive was false, then your original statement was false, right? They will always match because it's just saying the same thing, but in a different way. That works with the converse and inverse as well, okay? It just works out how we move the pieces around, that they say the exact same thing, but in a different way, okay? So if converse is false, inverse is false. If inverse is true, converse is true. So in reality, you don't have to check all of these, right? You could say, well, the converse is an easy one for me to check if it's true or false. I'll just do that one, and I have my answer for inverse, okay? And then you only have to write the statement for inverse. And that, for this assignment, it might not be the most helpful thing, but for future problems, and like when we try to start doing proofs, this could be a very, very helpful tool, because sometimes when you read like the contrapositive, it actually ends up being a lot easier to check if it's true or false compared to the original, right? And that's very helpful in the math world when we're trying to figure out, is this thing true? Can I say this? Well, it might not be easy in this way, but if I rewrite it to the contrapositive, I might be able to more easily tell if it's true or false, okay? So that's just a little tip for you guys. So, long story short, given statement is the same as contrapositive, right? Your original is the same as contrapositive and whether it's true or false, and converse is the same as inverse on whether it's true or false. All right? Hopefully with these two examples, you kind of see the thought process and how we work through these problems. And if you're still struggling on how to write the statements, try to look at the previous two video lessons, right? That's what their focus is on. This one is more on truth, so I kind of skipped over that part in this. All right? If you have any questions, let me know. Try to get all of your assignments over conditional statements finished before we start next week, just to make next week easier. All right? Other than that, good luck on the assignment, and have a great day.